Hello and welcome to my video Algorithms versus Algorithms, Presets versus User-Defined. So let me begin by giving a little context here. I made a fairly extensive video on the OpSix and I've done another FM tutorial on the Liven XFM. I had a question in a poll that I ran to try and get some feedback about what sort of videos people would like to see. And one of the types of videos that was requested was a description of the differences between the preset algorithms like you get on the DX7 and algorithms made in the user-defined manner or in software like FM8. So that's exactly what I'm going to do. Let me start by describing what one of these algorithms is. So the algorithm is a connection of operators, an operator being an oscillator, an envelope, and possibly some other associated parameters. The algorithms define this connection in terms of what modulates what and what outputs to the mixer. So first, let's have a look at this diagram here and let's understand what it means. So the operators are numbered like dice, 1, 2, 3, 4, 5, 6. The signal flows top to bottom. The bottom row are the operators which are outputting to the mixer. So in this case, we can see operators 1 and 3 output to the mixer. Operator 2 is modulating operator 1. Operator 4 is modulating operator 3. Operator 5 modulates operator 4. Operator 6 modulates operator 5, and notice that little hook on the top of operator 6, that means operator 6 modulates itself. In fact, that self-modulation is the first way in which these preset algorithms differ from user-defined algorithms, at least on the OpSix. Specifically, when you have a feedback loop in a user-defined algorithm, the level of that feedback is defined as you set it in the algorithm. With these preset algorithms, there is a separate control in the miscellaneous page under the program miscellaneous. So setting this algorithm feedback amount is effectively setting the intensity of the self-modulation in operator 6 here. So that's how the flow works. Now I'm going to describe how I'm going to demonstrate this in practice by making user algorithms. Well, what I've done is I've taken screenshots of a number of these algorithms. You can see the first one I'm showing here is the one that's already on screen. And I'm going to recreate these in the FM routing or user-defined algorithm. So first, I'm going to switch to the user algorithm. This is the default user algorithm. I'll explain what it means when I go to edit. So miscellaneous, user algorithm edit. So what we have here at the moment, this matrix represents the connections between the operators and whether or not operators output to the mixer. So there are two pieces of information here. The bottom row with the down arrow or the cross represents whether a given operator is outputting to the mixer or not. The mixer output is not a level that you can set on this synthesizer. It simply either outputs to the mixer, meaning we call it a carrier, or it does not output to the mixer. If it modulates something else, it's called a modulator. So things can be both modulators and carriers potentially. So let's start by thinking only what outputs to the mixer. This is actually on a second page. So looking at the algorithm, operator 1 and operator 3 both output to the mixer. So we have that configured. Let's go back to the first page and now let's describe what the rows mean. You can think of each row as corresponding to one operator, specifically the input of that operator. You can think of each column as corresponding to one operator, specifically the output of that operator. So the filled in cell in the second cell in the first row is the output of operator 2 going to the input of operator 1. In other words, operator 2 modulating operator 1. So we can see that the default algorithm actually includes the first of the connections we want to make. So let's go on to making other connections. Second row corresponds to operator 2. Is operator 2 being modulated by anything? No, it is not. So this is already correct. Let's move to operator 3. Well, what is operator 3 modulated by? Above operator 3 is operator 4. So operator 4 to operator 3 routing. You may ask yourself, well, this is a percentage. How is the percentage related to the connection? Well, in the preset algorithms and in the DX7, these routings would always be 100%. So the user algorithm actually gives you some additional dimensions to experiment. But don't attempt to set these to any other value if you're trying to recreate an algorithm. So that's 100%. So operator 3 is modulated by operator 4. Next operator, operator 4. Well, operator 4, we can see in the diagrams modulated by operator 5. Operator 5 is modulated by operator 6. You could see that operator 6, the light just came on in this purple color, indicating it is now a modulator. And finally, operator 6, you see the feedback loop is modulating itself. Now this is a slight deviation from the regular process. Remember I said that with the preset algorithms, we have a separate parameter to adjust feedback. In user algorithms, we do not. So that means that if that parameter that I described were not turned above 0, then this self-feedback would be 0. So as we adjust the program miscellaneous algorithm feedback setting, it is equivalent to adjusting this self-feedback amount. So let's have a quick look at this again, just to double check. Operator 1 is modulated by operator 2. Operator 2 is not modulated by anything. Operator 3 is modulated by operator 4. The way that I'm reading this, by the way, is I'm looking at the row and I'm seeing which column is filled in. So in the fourth row, the fifth column is filled in. In other words, operator 4 is modulated by operator 5, and so on. So I think I've done the correct thing here. I'm now going to move to another algorithm, and I'm going to clear this, and we're going to go and try and make it. It should be relatively straightforward. So let's go to operator 1. Operator 1 is modulated by operator 2. Correct. Let's go to the mixer page. Operator 3 is outputting to the mixer. Let's go back to the first page. Operator 2 is not modulated by anything. Operator 3, this is an interesting one, is modulated by both operator 4 and operator 5. Operator 4 is modulated by nothing. Operator 5 is modulated by operator 6. Operator 6 is modulated by itself. So again, this is that other parameter that we have available to us. Algorithm made. Straightforward. Let's do one more example and then I'll move on to FM8. So next one, let's see. On the second page, operator 1 is outputting to the mixer. So is operator 4, and so is operator 5. That's the bottom row of the algorithm. Operator 1 is modulated by operator 2. Operator 2 is modulated by operator 3. Operator 3 is not modulated by anything. Operator 4 is modulated by operator 6. Operator 5 is modulated by operator 6. And operator 6 is modulated by itself. So we've gone through and we've copied those preset algorithms into the user algorithms. Now I'm going to switch over to FM8. And I'm going to describe how this operates. So it's very similar. In fact, it's almost identical, but the way it's visualized is slightly different. So firstly, instead of numbering the operators 1 to 6, they are given letters A, B, C, D, E, F. You may notice there are some additional operators listed here. These are special and they are not regular FM operators. Specifically, X is a noise operator. Z is a filter, and in is the audio that's coming into this plugin. So how exactly do we read this? Well, just like on the OP6, each row represents an input and each column represents an output. So the inputs to operator A are in this row. The inputs to operator B are in this row, with the unfortunate exception, though it looks a little more like the algorithm, that the algorithm diagram, feedback is placed above. So what else is happening here? What are these bottom rows? The very bottom row is setting the pan, in other words, stereo pan of each individual operator. And the one above there is the amount of that operator reaching the mixer. So unlike on the OP6, where we can only turn on or off to transmit to the mixer, in this case, we are free to set a send level. So let's start by setting those send levels for the carriers. So carrier, operator 1 is a carrier, A is operator 1. B is also a carrier, set that to 100, just like on the OP6, we want full level. But you may note that this is not displayed in white like that one is. Orange means which one is showing the context in the panel. White means it's on, so we have to right-click it to enable it. So now operator A and B, corresponding to 1 and 2, are enabled. Operator 3 is not a carrier. Operator 4 is a carrier, so I will enable it and I will send it to the mixer. So presently we have 3 operators all outputting to the mixer, but we have no modulation. So now it's time to add the modulation. But what modulates what? Operator 2 is modulated by operator 3. Operator 3, which we'll call C, so this is its output column, and this is B's input row. So I set that to 100. So in other words, operator C is modulating operator B, or rather in the nomenclature we're using for the other algorithms, operator 3 is modulating operator 2. Additionally, operator 3 modulates itself. This is the exception where the feedback amount is placed here. So notice the little feedback arrow is present there. So we have operator 3 modulating itself. Let's look for other modulations. I need to enable that operator. Operator D. Operator D is modulated, that's number 4, by both E and F, or 5 and 6. So this is the routing between 5 and 6. This is the route, 5 and 4, and this is the routing between 6 and 4. And let's enable those two. So let's have a quick check. Operators A, B, and D are all outputting to the mixer. Operator B is modulated by operator C. Operator C modulates itself. Operator D is modulated by both operator E and F. Okay, so I think that is correct. So let me open an empty algorithm again, just so I can start afresh. Let me set this to some default configuration, and let's go to the next algorithm. I'll do 3 here, and then I will be done. So let's start with the carriers. Operator 1, also known as A, is a carrier. Operator 3 should also be a carrier, so operator 3 is what we call C. Remember 100% modulation levels. So what else have we got here? What modulates operator 1? Well, operator 2 modulates operator 1. So the output of operator B, that's this column, intersects with the input of operator A. So connection made. Operator 3, what's that modulated by? It's modulated by operator 4, 5, and 6, also known as D, E, and F. I can enable all 3 of those, and finally operator 6, also known as operator F, has feedback. So there is feedback. So this is the algorithm implemented here. Let me load empty preset again. And let's finally go to the last algorithm to implement. This, I remember, is, and maybe even the previous one, is not a DX7 algorithm. It's one of the OP6 specific algorithms, but in a synthesizer like this, or in anything that has 6 operator user-defined algorithms, you're free to define it as you wish. So let's start at the bottom. Operator 1 is a carrier. It's outputting to the mixer. It is modulated only by operator 2, also known as operator B. What is operator 2 modulated by? It is modulated by operator 3, operator 5, and operator 6. Operator 3 is also modulated by operator 4, and operator 6 is modulated by itself. So let me turn all of these on. And here we are. So this is an implementation of that algorithm. It's not very difficult, but it does take a little bit of thought. So spend some time to practice, but it's relatively easy to translate these algorithms. One question is, why might you want to do that? Well, one reason might be that you have written somewhere some information about a DX7 patch which has a picture of the algorithm, and you want to implement that algorithm in a different FM synth. On the OP6, you have a list of all those algorithms, and I'm sure that list of algorithms is also available in FM8, but you can implement it yourself. Well, then why would you choose to do it in a user-defined algorithm rather than just using a preset? Because in a user-defined algorithm, you are free to adjust the routing after the fact. When you use a preset algorithm, if you change presets, the function and the ordering of all the operators will be shifted around. So it may mean that you fundamentally change the timbre in a way that you don't want. So user-defined algorithms give you maximum flexibility. And as a rule, on the OP6, on the Live-NX FM, and on FM8, I favor using user-defined algorithms at all times. Okay, so I think that's everything that I wanted to cover. I hope that was clear. All that remains to be said is I'd like to thank you all very much for watching and say goodbye.